Hey, welcome along to Top Shelf Tech. Today we're talking about data at the speed of thought. And we're very lucky to be welcoming back the team from Weka who have been guests with us before on Top Shelf Tech. Shimon, Bell, do you want to just start by introducing yourselves?
Sure.
Absolutely.
I'll start. So, hey, Shimon Ben David, CTO of Weka, been in the company for the last 10 years, based in the US. It's really interesting to see all of the evolution of technology and definitely of the company as well through the last 10 years. I imagine we'll talk a bit about that as well.
Absolutely.
And I'm one of the newer Wekis, actually, the polar opposite of Shimon's experience. Former CTO of NetApp SolidFire and on the governing board of Kubernetes CNCF, founding governing board, now principal product manager in charge of AI and open source.
Awesome. Well, thanks again for joining us. And, when we, just to sort of recap, when we last spoke, probably about two years ago, Weka was starting to do some pretty amazing things, in particular with use cases around VFX and some of the early AI pieces. Since then, what's changed? And with the rise of AI, how has that impacted sort of Weka and what you guys are doing?
Brilliant. Maybe I'll start. So it's interesting. We've been involved in AI projects from the genesis of the company. So when we had the product, when we started the product, we aimed it toward these AI markets because these were the emerging markets that required high performance. And it's interesting to see that at the beginning, in the early stages of AI, the bar for entry was very high. The bar for entry was you had to have data scientists, you had to know what you're doing, train models, do the math, bring up the environment, stitch everything together. What we're seeing with the latest AI environments, especially since Gen AI, is that the bar to entry has been lowered. So suddenly you can have AI companies that are doing mostly inferencing or not even doing inferencing, just like running agents that are calling remote inference agents. So we were seeing actually AI becoming much more dominant in organizations where you wouldn't have naturally seen them. And the outcomes are fantastic because eventually AI enables so many intelligent use cases where simply we wouldn't have seen that with that high bar to entry initially.
Awesome.
Yeah, and I would say, as we were joking backstage, there's kind of a few eras of AI now. There's the BCE, before ChatGPT era of machine learning and deep learning, where I spent a lot of time with some of the Kubeflow team and the Kubernetes team in the early days. And now we find ourselves in the AD era after DeepSeek, right? Two seminal moments, I think, in the industry with regards to, one, around scaling through better training, better data, more GPUs, transformers, algorithms. And now the new revolution we're just a week into right now with regards to limitless scaling at inference time through reinforcement learning models and then test time compute. So it's a breathless, as Shimon and I were joking over lunch, it's a breathless pace of invention, not just innovation in this industry. Great time to be alive if you get bored easily, but some just amazing new use cases, business applications, cancer drugs forthcoming, literally advancements in nuclear physics, in quantum physics, all enabled by this accelerated AI era.
And we probably don't use the term invention enough, don't we? But we really are seeing some of the stuff that's quite fascinating. And probably when I guess think about some of the components of AI, almost like a brain, and we talk about thinking that's been one of the big things that we've seen over the last year, that ability to reason and think. We've got a brain, we've got the processing unit. You need a memory. You need something to store data and to access data. How important is that, and the latency of that? We don't often get to see behind the curtain. We see the end consumer products. Behind the scenes, how important is that kind of neural connection, neural network to the memory in the sort of brain?
Yeah, it's a fascinating comparison because I think. Oh, sorry, Val, I'll take this and then.
The protocol is simple. We'll let you take a first crack at it.
See if you succeed, then fix whatever you couldn't. That's brilliant. Love it. Yeah, I'm opinionated, so I always like throwing my opinions. So where were we now? I need to.
Memory and latency are our favorite topics.
I think the topic is like we usually, when we're talking with AI consumers, even scientists, practitioners, they don't necessarily even attribute any value to storage. For them, most of the problem is compute bound, GPU bound. Maybe they even understand that it's GPU memory bound in some cases. Storage is almost like an afterthought. Storage is there as an API. It's not even an appliance. It's not even a storage environment. It's an API that they just consume and put and pull data. Under the hood, there's a lot of internal workflows within these frameworks that copy data between different environments to local NVMEs. It's being taken care of for these practitioners. What we're seeing is that, but as you mentioned, storage has, or data actually, storage is just a facility for the data. Data has a meaningful impact because the basic example is if you're training a model, the more data you feed the model training, the more accurate the model will be, right? So obviously there's an importance to the amount of data, obviously also to the how good the data in, right? No garbage in, garbage out, but data manipulation, data access is immensely important. Initially, there was the thought that mostly in training, data is important. But after you created the model is loaded into GPU, so therefore there's no necessity for the data because the data was needed to create the model. But what we're seeing is as things evolve, as Gen AI and LLMs and transformers technologies evolve, what we're seeing is that actually at scale, data is again a challenge because these LLMs eventually, like just talking about the basics, these LLMs eventually are files, saves as a file. In order to have 1,000 GPUs, access them, load them, activate them, they need to be distributed in a reasonable way. We're seeing customers that have hundreds of terabytes of model repositories or model registries that needs to be managed in an effective way. More than that, if you're looking at the new technologies, if you're looking at RAG, retrieval augmentation, where you have massive vector databases that holds embeddings of data, so the LLMs would be able to access more concurrent data and hallucinate less, so bring more concrete, up-to-date answers. That's a massive data challenge because if you're looking at a data point, when you're embedding it, there's a 5 to 15x amplification. So a petabyte of data now becomes 5 to 15 petabyte of data when you embed it, only so that the LLM can consume it. And that's not even talking about different chunking mechanism, different re-ranking algorithms. So the data challenge is still there. And actually, let Val introduce the next topic, which is near and dear to us now, and it's our next passion.
Yeah. So very much, the way to think of it is memory is the new storage in the GPU era, right? Where we access data in parallel on behalf of tensors that have hundreds to tens of 20,000 dimensions. And so the reason why the GPUs are so valuable today, $40,000 each, is that they're able to process all this data in parallel. And one of the key structures we're seeing right now, as Shimon mentioned, is the action is in memory. The action is how do we keep this very expensive GPU busy, delivering value, not trying to read data into memory. That should be optimized earlier in the pipeline. And a very common structure with transformer algorithms is to effectively transform data, tokenize data into key value vectors, KV caches. Whether it's caching input prompts or certainly now processing reasoning tokens and creating output tokens and outputs, KV cache becomes a real bottleneck. One of our colleagues, Callan, also from down under, likes to joke that GPU memory is the most expensive real estate in the world right now. We often find when we talk to inference experts at small and large AI companies, GPUs are not even the bottleneck at inference time. Memory bandwidth, particularly MBU is the metric, memory bandwidth utilization is the bottleneck. And so we are in this envious position of having extremely low latency, data and storage platform that has all the characteristics of random access memory, the low latency in the milliseconds, in the microseconds, as opposed to milliseconds for traditional storage or nanoseconds for HBM high bandwidth memory. Being able to fill that giant gap between nano and milliseconds with microsecond latency enables us to behave to an LLM, to an inference server like NVIDIA's Triton TRT LLM or the popular open source VLLM enables us to behave just like memory to them. And in fact, and even a faster tier in some cases because of the algorithms than the CPU DRAM or Redis or Memcached. So that's really, really exciting because people are always puzzled how we can be faster than local storage. Now with these inference serving optimizations, we're faster than even CPU memory in many cases for these apps. So it's a whole new world. And imagine terabytes and petabytes of memory now for these models that will unlock new science and new inventions and next generation DeepSeek models.
I think,
maybe I'll
yes.
Sorry, I'll add to that. If we're looking at the direction of looking at Weka as an extended, as Val mentioned, as an extended memory for the GPUs, because it really has the characteristics of microsecond environment and not a millisecond. So it really is fitting in the middle. We're now also looking into what can we do in these AI frameworks that would benefit it, because we're seeing customers using, or AI organizations that are starting their journey or somewhat even a bit more into their AI journey. We're seeing them taking the common practices of how you move data around, how do you handle data, copying data between different locations, and utilizing these, I would say, yesterday technologies or concepts with where we perceive the Weka capability now with AI is actually to accelerate these AI frameworks. So we're not shy of going into these new AI frameworks. So not the product itself. The product is already here. It's amazing, microseconds, but going into these AI frameworks and changing them to benefit from Weka. Eventually, the value for the users, for the community, is going to be an accelerated inferencing, accelerated RAGs, accelerated training, tuning, retraining, accelerated AI environments, accelerated outcome, without handling the data storage itself, without trying to change their pipeline. They'll just utilize these environments, and these environments, as they understand that they're working on a Weka environment, they'll just take full benefit from it, and everything will just become accelerated. So this is something that is still in the making.
So we've got this amazing development going on around this sort of idea of memory and getting that optimized to the point that it's not the bottleneck anymore. And we've just seen a massive shift over the last week with the announcements coming out of DeepSeek. And previously, I guess a lot of these components we're seen as, you had to be a hyperscaler, you had to be a Meta, you had to be one of the big players in AI. Now you've got an open source model, and you got Weka, which actually anybody can call you guys and use Weka on the cloud, use Weka sort of in their own private infrastructure. How has this changed the ability for other entities to maybe piece together their own AI environments and I guess almost democratized this technology already that had very quickly actually became almost a bit of a narrow field who could afford to play in this space?
So I'll take a shot at it, Val, if you don't mind.
Sorry, it's a very big jumbled question. I hope you understand what I'm asking.
No, yeah, I'll talk to the topic. Funnily enough, we're seeing that customers are still exploring, customer organizations are still exploring AI environments, and even with the publication of open source models, starting with Llama, for example, again, the bar to entry just dropped and everybody can become a player. And then it's the next level of challenge of how do you do it at scale in an ROI makes sense? How do I do it in a way where the benefit is improving, not doing it, right? So we're seeing customers that are still trying to see how to do it in a production scale environment. What we did actually, in order to kind of encourage customers to learn from our experience with working with hyperscale customers on AI environments, we actually created a blueprint that we call WARP, Weka AI RAG Reference Platform, WARP. And that blueprint is actually, I would say it's a summary of our experience from some of our large-scale customers running AI environments, starting with as you mentioned, any cloud environment with the Weka, all the way up to where you're running your model with your vector database, and how is that connected? How does that scale? How do you create a Kubernetes environment and manage and operate it at scale? And we're seeing that as a blueprint that help customers bridge the gap between this is my end goal AI project, and this is where clouds and infrastructure is. What's in between? So that blueprint actually help them conceptualize, and downright they can just take it and adopt it. And it's a microservices environment that can scale and shrink as needed. It can go across cloud, cross on-prem. Obviously utilizing the Weka capability also for performance and moving the data around.
Awesome. And look, just to I guess, so lots of development in this area, and you guys building out some really interesting frameworks and technology to support it. Maybe just as a wrap, Val, from yourself, last thoughts on sort of what we've seen in the last week, where Weka's going, and what's on the horizon for us.
Yeah, just building off your last question, Jeremy, it's super exciting to see how accessible now this technology is. It used to be that the realm of training a foundational model required billions of dollars of capital, and that's no longer the case. It used to be that you had to have humans in loop in terms of improving the quality of the model during training, and with reinforcement learning we're proving now, that's no longer the case. So what's exciting to me is both ends of this spectrum. On the one hand, the technology is more accessible, which means more people, more diverse group of people get a chance to actually create new models that are super powerful. On the other hand, there's this disillusion, or I think this misbelief in the market that we saw yesterday with the reaction in the stock market that, oh my God, there's no more demand for GPUs, and oh my God, there's no more demand for AI infrastructure because it's so cheap. And this is a great reminder of studying the Jevons paradox, where obviously during the Industrial Revolution era, people thought after the first wave of factories that were powered by cheap coal, there wouldn't be much more demand for coal because who needed more factories? And it turns out that once you make a really valuable commodity cheaper, the demand surges. So what's going to happen here, what I like to call an echo effect, is yes, DeepSeek is resetting the fundamental economics of AI training and inference. But because now we can create more cool stuff and more people can create more cool stuff, we're about to see an acceleration in demand for cool AI agents and models and all sorts of LLM applications that we can't even imagine. And so this is going to create definitely more infrastructure demand, more pressure on scaling this efficiently because nobody wants to be uncompetitive on token economic pricing. And again, just to use the American analogy, we're still like in the first or second inning of this 9-inning baseball game. There's a long way to go, lots more science, invention, and of course, innovation to come.
Awesome. That's great insight. And I think, you have, it's reverberated around the world because it's reverberated through the stock markets, right? So it's, I think to your point around that demand and accessibility, it kind of allows us to get to that next stage. So look, just want to say thank you again for joining us today. Always great to have the Weka team on and chat to you. I always learn lots of things. I was going to say something new, but lots of new things every time we talk. So really appreciate your time today.
Thanks for having
Really
us.
enjoyed it, Jeremy. Thanks.
Great. Thank you.